the day Apollo 13 lost its oxygen. The mission was supposed to be a calm trip to the moon, until a sudden explosion turned the spacecraft into a freezing metal lifeboat. Apollo 13 was already far from Earth when an oxygen tank exploded inside the service module. At first, the crew heard a loud bang. Then warning lights started flashing. Oxygen began leaking into space, and the spacecraft started losing power. This is where it gets worse. Oxygen was not just for breathing. It also powered the fuel cells that gave the ship electricity and water. Without it, the astronauts had to shut down most systems and move into the lunar module, a craft designed to land on the moon, not keep 3 men alive for days. The real danger was not one single failure. It was a chain reaction. Cold, carbon dioxide, low power, bad navigation, and one tiny mistake could have left them drifting forever. The shuttle that broke apart in the sky. Space Shuttle Challenger looked powerful, advanced, and almost routine. But 73 seconds after launch, it became one of the most shocking disasters in space history. The problem began before liftoff. Cold weather damaged rubber seals called O-rings inside one of the rocket boosters. These seals were supposed to keep burning gas trapped inside the booster. But once the shuttle launched, hot gas escaped through the damaged seal. At first, it was a small failure. Then it burned into a support structure and caused the giant external fuel tank to break apart. This is where the disaster became impossible to stop. The shuttle was traveling faster than sound, under extreme pressure, with millions watching live. In seconds, the vehicle vanished in fire and smoke. The real danger was not just the technical failure, it was the belief that a known risk could be managed one more time. The fire inside Apollo 1. One of NASA's deadliest disasters happened before the rocket ever left the ground. Apollo 1 was sitting on the launch pad during a routine test when a fire suddenly broke out inside the capsule. The astronauts were sealed inside, wearing suits, surrounded by wires, switches, and pure oxygen under high pressure. That detail made everything worse. In normal air, fire is dangerous. In pure oxygen, fire becomes violent. Materials that might burn slowly can ignite instantly. The crew tried to open the hatch, but the pressure inside made it almost impossible to move quickly. Within seconds, the capsule turned into a trap. The real horror was how fast it happened. There was no space vacuum, no meteor, no alien planet. Just a spacecraft on Earth filled with oxygen, where one spark became a disaster. It changed how NASA designed capsules forever. The Columbia disaster on re-entry. Columbia survived launch, completed its mission, and was almost home when the real damage finally revealed itself. During liftoff, a piece of foam insulation broke off the external tank and struck the shuttle's left wing. It did not look like a major threat at first, but the impact damaged the heat shield. That damage became fatal during re-entry. As Columbia fell back through Earth's atmosphere, air around it became superheated. The heat shield was supposed to protect the shuttle from temperatures that could melt metal. But here's the problem. The damaged wing let hot gas enter the structure. Slowly, the wing weakened from the inside. Sensors failed. The shuttle became harder to control. Then it broke apart high above Texas. The scariest part is that the astronauts were already on their way home. The disaster was not waiting in space. It was waiting in the atmosphere, the Soviet cosmonaut who could not be saved. Soyuz 1 was meant to prove that the Soviet space program was still racing ahead, but the spacecraft had problems almost from the beginning. Vladimir Komarov launched into orbit knowing the mission was risky. Once in space, one of the solar panels failed to open, leaving the spacecraft short on power. Navigation became difficult. Systems did not work properly. The mission was cut short, and Komarov prepared to return to Earth. But this is where it gets worse. Re-entry worked, but the parachute system did not. The main parachute failed to deploy correctly, and the backup became tangled. The capsule fell toward Earth at terrifying speed. There was nothing mission control could do. The real danger of early spaceflight was that bravery could not fix bad hardware. A spacecraft may look like a machine, but during failure it becomes a falling box with a person trapped inside. The space station that nearly spun out of control. A space station is supposed to feel stable, like a floating laboratory above Earth. But in 1997, the Russian space station Mir became the scene of a terrifying accident. A supply spacecraft called Progress was being manually guided toward the station during a docking test. It came in too fast and crashed into one of Mir's modules. The impact punctured the station, causing air to leak into space. Suddenly, the crew had to find the damaged module, seal it off, and stop the station from losing pressure. But here's the problem. The crash also damaged power systems, and Mir began drifting. Without enough electricity, controls became harder to use. The station was no longer just a home in orbit. It was a damaged structure spinning above Earth. The real danger was isolation. If something breaks in orbit, help is not minutes away. It is hundreds of kilometers below. The rocket that exploded before leaving the pad. Not every space disaster happens in orbit. Some of the worst happen in the first seconds, when a rocket is still sitting on the ground packed with fuel. The Nedelin catastrophe in 1960 is one of the deadliest rocket disasters ever. A Soviet missile was being prepared for a test launch, but there were serious technical problems. Instead of fully clearing the area and delaying the test, workers and military officials stayed near the rocket. Then, the second stage engine ignited while the rocket was still on the launch pad. The result was instant catastrophe. Fuel exploded, fire spread across the area, and people standing nearby had almost no chance to escape. This is where it gets darker. The disaster was hidden for years because of secrecy. The real danger was not only the rocket, it was pressure, politics, and the decision to rush a machine that was not ready. The astronaut who almost drowned in space. Drowning sounds impossible in space, but it almost happened during a spacewalk outside the International Space Station. Italian astronaut Luca Parmitano was working in his spacesuit when water began leaking into his helmet. At first, it felt strange, like moisture collecting where it should not be. Then, the water spread across his face. In microgravity, water does not fall. It floats and clings. That means a small leak can become a moving bubble that covers your eyes, nose, and mouth. This is where it gets terrifying. Parmitano could not simply wipe it away. He was inside a sealed helmet, outside the station, with limited visibility and rising danger. He had to return to the airlock while the water kept building up. The real danger was how silent the threat was. No explosion, no fire, no crash, just water slowly turning a spacesuit into a trap. The disaster waiting in deep space. The most terrifying space disaster may be one that has not happened yet. A future mission to Mars would place astronauts millions of kilometers from Earth, far beyond quick rescue. If a spacecraft breaks near the moon, help is difficult. If it breaks on the way to Mars, help is almost impossible. Radiation from solar storms could damage cells and electronics. A life support failure could poison the air. A micrometeorite could puncture the hull. Even a small medical emergency could become deadly when the nearest hospital is on another planet. But here's the problem. Deep space does not forgive delays. Messages can take many minutes to travel between Earth and the crew, so astronauts may have to solve disasters alone. The real danger is distance. In low Earth orbit, Earth fills the window. On the way to Mars, Earth becomes just a bright dot, and survival depends entirely on the machine around you.